Hi all. Today we are going to discuss about two interesting problems in EMI. I'm going to display the first question here. Just go through that and I'm going to discuss the problem now. So let me draw the figure for the first problem. So if you read the problem, a rod is rotated in a circular fashion with omega speed, and here one static resistance is kept, and this rod has total resistance of R, so just the midpoint. So there is a resistance of R by 2 here and resistance of R by 2 here, and we have to find the direction of current, and we have to find out what is the current in the bar. So this type of problem, actually, first of all we have to decide where is the direction of EMF. So for that, like we have already discussed in my previous videos also, we can use our right hand palm rule. So the fingers will indicate about, now the direction of field is given like this. Okay, so if you open your right palm and point towards that field, and this because you are rotating like this, here some velocity v will develop, here some velocity v will develop, right? So the motion is in this direction, so you can see the motion is in the upward direction, this fingers pointing towards the B. So this white portion, this side you will have the high potential and this side you will have the low potential. Similarly, when you come this side towards the rim side, you will have high potential, and towards this side you will have low potential. So the figure will be something like this. Okay, so this can be also established by Fleming's left hand rule. So open these three fingers like this. This indicates the thrust, this finger indicates the field, and this finger indicates the direction of current. You can see here this finger is indicating this. So thrust here is in the upward direction and current is in this direction. So the current will be in this direction here and the current will be in this direction here. Okay, now if you see this PO resistor and OQ resistor, they are in parallel. All right, so R by 2 and R by 2, that means R dash will be equal to R1 R2 by R1 plus R2. So this will be R by 2 divided by R by 2 plus R by 2. If you simplify this now, you will get R by 4. So this figure actually will become something like this now. Okay, like this it will become. So this is R by 4 and this is R. Okay, so the potential here will be E. This potential we don't know, let us say X, and this point potential will be 0. So we can perform our nodal analysis. So we will assume that this potential is higher potential, that is the procedure we adopt in nodal analysis. So we can write like this. So difference of potential divided by resistance, that's the current, plus X minus 0 by R is equal to 0. This is like you have applied KCL basically. Okay, sigma I at a joint is equal to 0. So here R cancel. So after simplifying this, 4 into x minus e plus x is equal to 0, 4x minus 4e plus x is equal to 0, 5x minus 4e is equal to 0, 5x is equal to 4e, or e is equal to, we are trying to find out x now, x is equal to 4e by 5. So the potential at this point is x. So if you want to find out what is the current in that, we can take this particular portion. So v is equal to IR, so I will be equal to v, so which is x by r, which is 4e by 5r. So what is the value of E? So this case is actually similar to this case. A rod of length A is rotated with angular speed of omega. The EMF that is developed in the rod will be B omega A square by 2. So by substituting the values, we get I is equal to 4 by 5r into B omega A square by 2. So this will be 2 times B omega A square by 5r. That's your answer. So option 2 is correct. and also if you see the direction is from the rim side to the center. So the direction is rim to the center. Rim is at higher potential, center is at lower potential. Now I am going to discuss about the second interesting question. I am going to display the question here. Please read that question and we will have a discussion on that. So let me draw the diagram for the second one. In the second one, there is a conductor shown like this. One side is connected to an inductor, another side it is connected to a resistor. Okay, and there is a slider which is going with velocity v. This slider is a conductor. The field direction is given like this, and it is going with velocity v. So basically here if you read the question, he has also given how much distance the slider moved. It moved a distance of x is equal to 3 meters. And let us write the data that is given over here. The mass is 1 and initial speed 5 meter per second. Final speed is 1 meter per second. This L value is 2h and B value is 1 and R value is also given as 1. So we have to find out what is the total charge in the slider. We have to find out that. So here we can see, we can decide upon the direction of EMF here also. So it is moving in this direction. Use right hand palm rule. So the high potential point, so fingers are pointing in the direction of field, thumb is pointing in the direction of motion. So this is the high potential point and low potential point. We can also check Fleming's left hand rule. Okay, so the field is in this direction, thrust is in this direction, the current direction is in the downward direction. So the current actually is going like this. So here actually if you see, okay, this is the high potential point, no? So the current, I think I have taken the direction should be like this. Okay, direction should be like this. So I'll call this current as I1, I'll call this current as I2 and this current as I. Okay, we are not too much bothered about the direction over here. Basically by Fleming's left hand rule we can establish, if you have to establish the direction of current, you have to use the Fleming's right hand rule, and force for force you have to use the Fleming's left hand rule. Okay, now here I can write I is equal to I1 plus I2. I2 portion is going into the resistor, I2 is going into the resistor and I1 is going into the inductor. So we can say here that if you want to find I2, it will be E by R, which is BLV by R. Okay, and in the case of I1, here there is a change in current, so we can write I1 actually equal to L di by dt. I1 L di1 by dt is equal to L di by dt. We can write it as flux, no? We can write it as E actually. E is equal to L di by dt, right? So we'll do one thing. The force that is acting on the conductor will be equal to F is equal to, it will be m dv by dt. Of course it is a reducing one because the speed is reducing, is equal to ILB, that is the force in the conductor. So if you further expand, m dv by dt is equal to I1 plus I2 into L into B. So let us take dt to the other side. So this becomes m dv is equal to I1 plus I2 LB dt. So let me simplify it over here. M dv integration is equal to I1 plus I2 we have just calculated. I2 we will use this formula. So BLV by R into dt integration. So this is from 5 to 1 actually. Okay, so we will write mv from 5 to 1. This becomes I1 dt plus BLV by R into dt. Okay, So we can see over here that this term itself is giving us q value. Okay, so we can write this as q plus BLV by R dt. Okay, so this is minus m value is how much? M value is 1 minus 5 is equal to q plus BLV by dt. Okay, here we have to multiply with LB also. We are missing the term LB here, so one term LB will come here. Okay, so this will become LB, and here also LB is there, no? So it will become B square L square. One LB term is there here, I into LB. Okay, this is I part. I into dt we have done, because dt we are taking to the other side. So let us simplify this. This becomes 4. So L value, the length of the conductor is given as 1 meter. Read the problem. So 1 into q plus, we are trying to find out this q value. Okay, so I dt I am writing it as q. Okay, so b square is 1 square divided by r value is also given as 1. Now integration of v dt. Okay, integration of v dt, what does it give? Integration of v dt will give us displacement. Fine. So which is given as, this value is given as 3. So 4 plus 4 is equal to q plus, this is 3, so q is equal to 1 coulomb. Okay, that's how we can solve. Basically what we have done, we have written this in the integration format, and we have calculated the q value using the formula q is equal to integration I dt. Okay, so like this you can send your interesting doubts to me in my WhatsApp, and I'll try to answer them, and you can see some problem solving approaches which can help you in your competitive examinations. Okay, take care then, bye.